Hello, it's Andy here, and welcome to episode 9 of my Sans 2018 Holiday Hack walkthrough. Last time it looked like Hans's evil plan had been foiled, but Santa still has a couple more requests of us. Before jumping into the main objective, we'll quickly drop in on Sugar Plum Mary, who has a cranberry pie terminal challenge for us. Sugar Plum's terminal is stuck inside a restrictive Python shell that she wants to escape from. It seems like she should head on over to one of the speaker rooms and check out Mark Baggett's excellent presentation on escaping Python shells. Luckily, this was one of the talks I managed to get in before the toy soldiers started going crazy. If our objective is to run the iEscaped program, the easiest way to do this is to use Python's built-in system command to launch a new process. To test the feasibility of this approach, we'll start with just attempting to run the id command, which should just tell us our user ID. But it looks like we're denied from doing so. It seems like whoever set up this system is looking for any code which contains the os.system string and just drops it and replaces it with this access denied message. Mark discusses this in far more detail in his talk, so you really should go and watch it. He mentions there's several commands which allow for breaking out of a restrictive shell, and so are usually filtered. These are import, exec, eval, and compile. If we run each in turn, it looks like all are indeed filtered, apart from eval. So we can wrap our command line inside an eval statement and split it into at least two smaller strings in an attempt to circumvent the filter. If it's blocking access whenever it sees the string os.system, then splitting it down the middle should be enough to evade that detection code. But instead of seeing the output of ID, we're told that OS cannot be found. This package probably isn't imported yet, or has been erased from memory. We'd normally import it with the import command, but we know that's restricted, so we use a similar technique to call the import function. We can then rerun our os.system command, and sure enough we see the output of ID. We just need to replace ID with our iEscaped command, and we've successfully completed this terminal. Now to get back to our main objective. We need to access Santa's web-based packet capture tool and decrypt some HTTP2 network activity. This should reveal to us a document sent from Holly Evergreen to Alabaster Snowball, which in turn should contain the name of a song. Navigating to the packet capture site, we see we need some login credentials. Let's try Sparkle Redberry's credentials from the last episode's terminal challenge. But no, these do not work. But wait, there's a register button. Can we just create our own account? Well, yes we can. After logging in, we're presented with a few buttons. One to upload a PCAP from our browser, another to capture some traffic, and a couple of screens showing user information and a list of capture files. The main interface shows an analysis of the captured packets, but it doesn't really show enough detail. Thankfully, we can download this PCAP and open it up in Wireshark though. All the traffic seems encrypted with TLS 1.2, so we're probably unlikely to be able to decrypt this through some sort of cryptographic weakness. Maybe Sugar Plum Mary can point us in the right direction. She tells us a lot of gossip about this app. The fact that it was rushed and has development code in the web root, that there's comments in the HTML which lead to exposing the server-side source code, that there was suspicious-looking development code using environment variables to store SSL keys and open up directories, and that manipulating values in the URL gave back weird and descriptive errors. She goes on to hope that these errors can't be used to compromise SSL on the website and steal logins. Okay, so it seems like our attention should be on the web-based analyzer rather than the PCAP itself. Let's see if we can find those HTML comments that Sugar Plum mentioned. We can see a reference to a pub folder and an API folder, and then in the embedded JavaScript there's a reference to data being validated on the server side by code stored in app.js. Sugarblum suggested that code had foolishly been left in the web root, so let's see if we can find it. And here we go, the server-side code is accessible from the pub folder. Reading through the code, we see that extra folders are opened up if a dev mode flag is set. The list of folders to be opened up is provided by the environment variables in the loadems function. But bizarrely, any environment variable which is set will be interpreted as a folder to open up access to. A quick search for that dev mode flag shows that it is indeed set, and that this mode also causes SSL keys to be logged. They're in a folder which is referenced by a couple of environment variables. Part of the hint made reference to some URLs producing weird error messages, so let's try and generate some and see if we can expose the contents of those environment variables. If we try to navigate to dev, there's nothing of interest. And if we try to navigate to SSL keylog file, the name of another environment variable, we get a bigger output. It looks like whatever environment variable name we put into the URL gets the contents echoed back to us. We now know the name of the keylog file and the path where it resides, and we know this folder's access has been opened up. We just need to specify the right URL, and we can grab a copy of the key file. Now, this is only the keys for traffic captured very recently, so let's go back to the web app to run a fresh capture. And now we can grab the keylog file, which should contain the keys for the data we just captured. Downloading the capture and opening in Wireshark shows us the encrypted traffic again. We just need to specify the keylog file in the properties, and Wireshark decrypts our traffic for us. We see several login attempts to the packet analyzer, along with the credentials used for each. Let's try logging in with each and see if there's anything of interest. After a couple of false starts, we find that under Alabaster Snowball's account, there's a saved PCAP called Super Secret Packet Capture. We can download and open in Wireshark and see that it's SMTP email traffic. If we follow the whole TCP stream, we can see the message headers and body along with the attached file encoded in base64. This message is from Holly Evergreen to Alabaster Snowball and seems to be about music, so this is probably the document that's referenced in the challenge objective. Here I copy and paste the base64 content into CyberChef to decode, and we can see fairly quickly that this is a PDF file. CyberChef lets us save the output as a file, which we can then open locally. On the second page of the document, there's a reference to Mary Had a Little Lamb. We successfully submit this as the answer to complete this objective. We don't get any extra storyline narrative upon completion, so hopefully Hans's plot continues to be foiled. I guess we'll find out in the next episode, where we'll also tackle the beast that is objective number 9. I'll see you there.